In this video, we will be looking at literal equations. This will be page 28 of your composition book. And let me go ahead and put the book aside so we can deal with just this sheet of paper here. First off, what we need to do is identify what a literal equation actually is. So we're going to define that. A literal equation is an equation where variables represent known values. An example would be distance, time, interest, and slope. Basically, they have more than one variable. So we have an equation where variables represent known values such as distance, time, interest, slope. There's usually more than one variable. And what happens from there is that we are usually asked to solve for a specified variable, and we will use the same process that we use for solving when we have numbers. So we have these three examples here, so let's just start going through these examples. So we have this variable here of a diamond, and it's being added to a square being multiplied by a smiley face, and that's going to equal a heart. So the first thing we do, as in any solving any equation, we're going to look and see fractions. We don't have fractions. There's nothing we can put together here. There's no like terms to combine. We don't have the smiley face on both sides because it wants us to solve for the smiley face. So it means we got to get rid of the diamond and the square. So we're basically left with, can I add or subtract to make either the diamond or the square go away? I can definitely subtract to make the diamond go away. So I'm going to subtract the diamond, and what I do to one side, I do to the other. So right here we will subtract the diamond. When we do this, the diamond on the left-hand side will zero out. We are left with our square and our smiley face, and that's going to equal a heart minus a diamond. And let's fill in the heart. Please forgive my lack of artsy skills. Okay, so now we want to get the smiley face by itself. So what we're going to do now is divide both sides by exactly what is in front of the smiley face, and that happens to be a square. So we will divide both sides by the square. Now this division, the same thing top and bottom, just means they cancel out because they make one. So my smiley face is equal to a heart minus a triangle, or a diamond, sorry, minus a diamond, all over a square. So we could write that a little differently, but I'm just going to go ahead and leave it as one large fraction. So let's try something that has some actual letters in it. That might be a little easier than the symbols. So we are going to use A equals F minus I over T, and they want us to solve for F. So in this case, this is seen as one piece, and we have a fraction here that we need to clear. So what we're going to do is we're going to multiply both sides of the fraction by the variable t, because that's what's in our denominator. So we distribute it. T times A is AT. This T comes over here, those cancel out, and that leaves us with F minus I. So what we did was we cleared the fraction by multiplying by t. At this point, we need to get the f by itself, so we need to get rid of subtract I. So what we're going to do is the inverse operation of add I. So we're going to add I to both sides. These guys are going to zero out on the right-hand side. On the left-hand side, I get AT plus I equals F. So what I did there was I added I to both sides. The last thing we do is simplify. There is nothing I can put together here. They are not like terms. So I am already in a simplified version. Okay, in our final example, we're going to look at solving for y. This is a skill that we need to have for our upcoming Unit 3 on linear equations, and this is actually a linear equation in standard form. So what we're going to do here is solve for y, so that means that the first thing we need to do is subtract the x term. So I'm going to subtract 2x from both sides. These zero out. We are left with negative 3y equals 6 minus 2x. Now I need to divide by whatever is in front of the y. So I'm going to divide by negative 3. And when I do that, I'm going to divide every single term by negative 3. Negative 3 divided by negative 3 is 1, so I'm left with y. 6 divided by negative 3 is negative 2. Negative divided by negative is positive, and I'm left with this fraction here of 2/3 times x. So to write that in our slope-intercept form, we would put the slope times the variable x minus the y-intercept. The pen is not writing well, pardon me. And always the last thing we do is simplify. So here we had an example with just abstract objects, an example where we needed to clear fractions, and then finally an example for solving for y. And this is an example that we will be practicing a lot over the next few weeks. Now here are 3 practice problems for you to look at and do. So if you would please go ahead and pause the video now and then come back and I will show you the answers to each of these. Alright, so that should have been you coming back from the video. So example 1 says E equals mc squared, and we're going to solve for m. M is being multiplied by c squared, so we are going to divide by what is being multiplied by that m. We have E over c squared equals m. For problem number 2, we have perimeter. Perimeter equals twice the length plus twice the width. And they want us to solve for W. So the first thing we do is get rid of the 2L. We're left with P minus 2L equals 2W. Now we have to get rid of the 2 in front of the W. So we divide everything by 2. This leaves us with P over 2 minus L, because these 2's are going to cancel, equals W. And then finally, in our third practice problem, we are solving for y. So I'm going to go ahead and just do this right up under the printed version. They are subtracting 3x, so that means we have to add 3x to both sides. These zero out. You're left with negative y equals 3x plus 2. Then we're going to divide everything by negative 1 because there's a negative sign in front of that y. So y is going to equal negative 3x minus 2. So here we have literal equations where You don't have a whole lot of numbers usually, mostly a lot of letters. Here are 3 examples and extra practice problems. This particular problem, you need to be able to solve this equation for W. You will also need to be able to solve it for L, and that is something we will be practicing in class. So here are your examples for literal equations.